This video is going to be talking about the LoR framework and what it does to help reduce the learning curve associated with building React applications. In a previous video, we talked about how there are two core experiences when using React. The beginner or getting started experience associated with learning all of the libraries required and piecing them together to form a functional application, and the practitioner's experience that encompasses all of the real-world concerns you need to solve for when building a large single-page application. This video is going to be focusing on what LoR does to improve the getting started experience when building a new React application. But first, for just a moment, I want to talk about the server side. Every widely used language today has at least one modern web framework, and if you've ever used one of them, you'll know that you get a lot for free. From the moment you create your first project, the initial ramp-up experience is often so seamless and so easy that for a long time you can stay completely oblivious to how any of it actually works. Conventions can be extremely powerful, and by creating a single model, you often get a full set of endpoints for interacting with your data. These frameworks take the approach that instead of asking you to compose the server yourself, i.e. to build it from its component libraries, they instead start with sensible defaults and ask you to learn about things when you need to in order to override those built-in behaviors. And for the most part, the framework stays out of your way. It enables you and it guides you, but it does not force you to understand it. And that simplicity and that early sense of competency is the feeling that LoR is striving to create for React. In a previous video, we talked about how the getting started experience with React right now is a bit like an uphill climb, because it's really up to you to understand all of the libraries involved and piece them together in order to build a functioning application with a good client-side architecture. And the analogy I used for LoR was that it was more like a resort island, and that when you visited it, it was really your choice what you wanted to learn and when, based on the specific needs of your application. So for this video, we're going to be visiting each of the destinations on this island to better understand how LoR simplifies their experience. And we're going to start by first arriving at the island, which is an analogy for creating a LoR project. So LoR itself is split into two core libraries, the main framework and the CLI. To create a new project, you first install the CLI, and from there you create a new application. And it generates the skeleton for a new project that looks like this. Once the project is created, you can run npm start, and you'll be able to navigate to localhost 3000 to view the project. And that's cool, but you also could just clone any example project on GitHub and get a similar experience. So that's more just a nice to have, as it's a pretty standard expectation of any framework. The rest of this video will break down each of the main libraries that LoR uses to explain how and why it simplifies the getting started experience with each of them. So now we have a basic project structure in place, but we still need to learn about React. For that, we're going to walk over to the Visitor Center, and they're going to have us learn about React by first visiting the React website and following the tutorial to build this nifty commenting app that we can play with in the browser. And at that point, we're ready to write React code. Since LoR's goal is to enable you to focus solely on React itself, the first thing it does is take care of some basic needs. There's an index.html file at the root of the project, which is what gets served to the browser. You can see a div where the application goes, another div to help with dialogues, and the bundle.js file that's generated by Webpack. The index.js file is the main entry point for the application, the target that Webpack uses as the entry point. This file is responsible for pulling in LoR, which goes through all of the files and folders in the project and ultimately builds the application and mounts it to the DOM. This means that you don't have to worry about how to mount a React application, and you're freed up a bit to just focus on building components. And for that, we're going to look at the source directory. There are two components that LoR provides by default. The first component is master, which wraps the entire application and ultimately determines when the rest of the application loads. A common use case for this component would be to display a loading experience once the application is mounted, such as while you're waiting to fetch information about the current user from the server. Additionally, the master component is also automatically subscribed to the Redux store, which means your application will automatically re-render as data changes. In most cases, excluding performance optimizations, this is the only component that will need to be subscribed. This component is more about function than form, however, as it primarily exists to drive behavior. The other component, layout, is all about form. The layout component is just a placeholder, and it's recommended that you use this to describe the structure of your application, especially if you have components that are always displayed regardless of the current route, such as a static header. Now keep in mind that you don't have to use either of these components, and there's nothing magical or critical about either of them, and you could in fact delete them both. They simply exist as a recommendation for a good development pattern. So to review how Lore helps with React, the CLI can generate a project template, which is pre-configured and ready to be served. Lore itself takes care of mounting the application to the DOM, which includes setting up and integrating Redux and React Router. The master component is pre-subscribed to the store, which means your application will automatically re-render when data changes. And all of this together means that you can focus on your components from the moment the project is created and not the things around them. The first destination we're going to visit on the island to learn more about what Lore provides out of the box is Webpack. There are two things that Lore includes to make it easier to work with Webpack. The first is the server.js file at the root of the project. When you run npm start to serve the Lore application, it actually runs node server.js to execute this file, which in turn invokes Webpack to build the project as well as serve the result from localhost 3000. Now it turns out that the built-in development server for Webpack, the one that you learn about while following the Webpack tutorial, doesn't actually work as is for single-page applications that use routing. If you try to use it and you refresh the page while on a nested route within your application will not reload as expected. Instead, to get routing to work in a development environment, you actually have to configure and invoke the Webpack development server yourself, which is what this file does. But having this file included in the project by default means it's not something you have to worry about unless you need to customize its configuration. The second Webpack-related feature of Lore is this Webpack config file at the root of the project, which is actually a wrapper around the Webpack directory. So the reason Lore uses a directory structure to represent the Webpack config is so that you can easily support multiple Webpack configurations on a per-environment basis. What that means is that your actual Webpack configuration is a combination of the common Webpack config file plus whichever config file in the /env directory matches the current node environment. Now these file names are not special, so if you need to support additional environments, such as staging, you can simply create a staging config under the /env directory and set your node environment accordingly. The common Webpack config also comes with common loaders pre-installed to make it easier to drop files into your project and immediately use them. As you become more comfortable with Webpack, you can tailor this file to reflect only the specific needs of your project. So let's review how Lore helps with Webpack. First, the common loaders come pre-installed, which means Webpack stays out of your way. The modular configuration setup allows you to override settings on a per-environment basis, which is important because development and production often behave differently. It also provides a customized Webpack development server to improve the development experience by providing support for routing. And all of this together means that you can basically ignore Webpack until the needs of your application demand that you can't. The next place we're going to visit is Redux, to learn more about what Lore provides to simplify the burden of designing the client-side architecture. To illustrate the value proposition for Lore, we're going to start by building up a raw Redux application. Here we have an application that allows people to post content to various social media platforms, and what we want to do is create a post. So the first thing we're going to do is create an action for creating a post. When invoked, this action creator will make a request to the server and send along the data that represents the post. The API server will create the post and send a response back containing the JSON that describes the post that was just created. The action creator will take this response, marshal it into an action, and dispatch that action to the Redux store. The store will in turn give each of the reducers a chance to do something with the response. So at this point, we also need a set of reducers. Since reducers represent the state of our application and the data structure that the components interact with, we frequently will create multiple reducers that store the data in a way that is meaningful for our needs. In this case, we've created a reducer that keeps track of our posts by ID, another that groups them by user, and a third that maintains a list of all posts retrieved. Once our reducers are done processing the action, our store's state updates and the application is notified. This in turn causes the application to re-render our components, and our new post appears within our application. This is a pretty typical interaction between actions and a set of reducers. So to illustrate the value proposition for lore, let's take a look for a minute at just the actions and reducers. So here we've got the actions on the left and the reducers on the right. And these were both created in order to interact with a post model. But in this example, we only had one action for creating a post. In reality, we'll frequently have a set of actions for every model so that we can create, update, delete, get specific posts, as well as an action for retrieving a collection of posts. Now, if we were to add a second model to view comments associated with posts, then we would also need to generate another set of actions and reducers in order to provide full CRUD support for comments, so that we can create them and edit them as well. So in this example, with two models, we have 10 actions and 6 reducers. But considering that it's not uncommon for larger applications to have 10 or 20 or 30 endpoints, it doesn't take much before we have dozens upon dozens of actions and reducers. So how does lore help? And the answer to that is that it takes a page from server-side frameworks and uses conventions. So here we have a beginning lore project. We have folders for our actions and reducers, but they are currently both empty because we don't have any. And just like before, we have this post model, and we need to be able to create a post. In lore, you do that quite literally, and you create a file called post in the models folder. This file is empty. It's the name that's important right now. And through conventions, recognizing the recurring patterns that naturally exist within actions and reducers, this empty file actually implies the existence of a full set of actions and reducers that support standard CRUD operations. So what do I mean by that? Let's use this component as an example. Here we have a React component that has a form, and the user is going to fill that out, and when they submit the form, we want to extract the title and create a post from it. To do that, we don't need to create an action, we just need to call it. Lore is the name of the framework, but it's also the name of a variable that all components have access to. And this variable hangs a lot of really useful things off of it, one of which are the application's actions. And every time you create a model, Lore appends the name of that model to actions and automatically fills it out with a full set of action creators for standard CRUD operations. These actions are derived from blueprints within lore that take advantage of the natural patterns and actions and reducers that we mentioned previously. We'll continue this example to illustrate. Since we're trying to create a post for this example, we'll do just that. So here we've called lore.actions.post.create and passed it an object with the data that we want to send to the server. So let's focus on that for just a minute. Here we're looking at just the call to create a post. When we make this call, Lore will automatically send out an AJAX request to the server, which we specify elsewhere in the application and pass along the data that we provided. In addition to the blueprint for a create action, Lore also provides a blueprint for the update action that will make a put request to update a resource, a delete action that will send a delete request to destroy a resource, a get blueprint to retrieve a specific resource, and a find blueprint to retrieve a collection of resources or perform a search against an API endpoint. So to recap, the creation of a post model implies by default the existence of create, update, and destroy actions, as well as get and find actions. And the reason that we've broken out the get and find actions is because they deserve a little more attention. Instead of calling these actions directly, the more common usage is handled by the framework itself, as it allows components to declare the data they need directly. To illustrate, we're going to take a look at this component. This component is responsible for rendering a list of posts, and to do that, it needs a set of posts to render. So how do we get our set of posts into this component? And for that matter, how do we fetch the list of posts from the server? Well, both of these questions are answered by a decorator that Lore provides. So this component is an ES5 component. And what we're going to do is we're going to move it down and we're going to decorate it with the lore.connect decorator and indent it for readability. So here we have an ES5 version of a decorated component. But for these examples, it's a little easier to read the ESNext style, the upcoming version of ECMAScript. So we're going to quickly refactor. So we'll remove our indentation and convert our React component to ES6 and our decorator to the ESNext style. And for now, we'll just focus on the decorator. So this syntax inside the decorator is pretty minimal, but it actually does quite a bit, and it's easiest to think of it as a question and a command. The question is this: has the post.find reducer set a value in the store's state? Now remember that at this point, we haven't created any actions or reducers explicitly, but that the existence of this model implies support for CRUD operations, and that includes a set of reducers. So when we ask about the post.find reducer, we're referring to this reducer that was created by a blueprint. And as a Redux refresher, a reducer structure like this will typically compose a store state structure like this, where the folder structure mirrors the object structure. So when we ask whether the post.find reducer has set a value in state, we're really looking to see if state.post.find has a value that is not the initial default. So back to the question. If the answer to the question is yes, this decorator will extract that data from state and pass it into the component as props. If the answer is no, and this is where some of the magic in lore really starts to happen, it will automatically call the action responsible for retrieving that data. And once the application has the data, the store will update, the master component at the root of the application will get notified, and the application will re-render. In other words, this is that same interaction in comic form. Our decorated component on the left says, "Yo, I need all the posts we have. Give me everything in state.post.find." And lore says, "Hello, it looks like we haven't fetched any posts yet." And the decorated component says, "Then go get them, please." And lore says, "Okay, retrieving them now." Off it goes to get them, and the component says, "Thank you." All right. So now that we understand the concept, let's walk through some of the typical questions we might want to ask inside this decorator. The first is the example we just covered, to retrieve a collection of posts. So if we ask for post.find, and we haven't fetched any posts yet, then lore will execute the post.find action, which will make an AJAX request to retrieve the collection of posts. If instead what we want is a subset of the posts, we can pass in a where clause, which will get passed to the action and become a network request to search the post's endpoint. We can also request a post by ID, a common usage of which would be to retrieve data associated with a specific route, such as the post corresponding to the post ID in a URL, which is provided to us by React Router. So to recap what all of this means, if we go back to our project structure, we have a single post model. And the existence of this model implies the existence of a default set of actions and reducers to support standard CRUD operations. If we need to interact with another resource, such as comments, then we simply add a model called comment. And lore will in turn generate a series of actions and reducers to support standard CRUD operations on comments. So that's all fine and dandy, and it's nice to get things for free as it allows you to focus solely on your components. But conventions fall apart when servers don't have conventions themselves. So what happens if you have an endpoint that lore's conventions can't map to? And in that case, you just override lore's default behaviors. To illustrate, let's say we need to customize the create action for a post. To do that, we simply create our own action under actions/post/create. Once we do, lore will notice that we've created our own create action for post, and it will use that one instead of the default. Reducers follow a similar pattern, and you can also create your own actions and reducers to extend those provided by the framework. For example, if you were to create a custom reducer under reducers/post/custom, replacing custom with whatever you actually wanted to call the reducer, lore will pick it up and add it to the list of available reducers for post. To recap how lore helps with Redux, lore uses conventions to automatically provide a full set of actions and reducers for any models, which you can then override as you need to. Lore also has a decorator that allows components to declare the data they need, which is then lazy loaded on demand. Now, while we didn't talk about this point, all of this is in fact highly configurable, and lore is capable of interacting with multiple API servers and can change many settings on a per model basis. In summarizing all of that, lore basically allows you to ignore Redux until the needs of your application demand that you can't. So our next stop on the island is React Router. So the truth is there isn't too much that lore can do to improve the experience with React Router, as it's fairly simple as is. But one thing Lore does do is automatically hook it into the application so that you don't have to set it up yourself. That being said, the routes.js file at the root of the project is where you specify the route hierarchy for your application. It's broken out to be clear and easy to find. If you need to change any of the configuration settings for React Router, you can do that in the config directory. The config directory contains files that enable you to control all of the default behaviors in Lore, but in this section we're only interested in one of those files, which is router.js. This file contains all of the settings that end up being passed into React Router when Lore builds your application. The default history type, for example, is push state, otherwise known as browser history in React Router. So if you wanted to change the history type and use hashtag routing instead, you could toggle that setting in this file. Additionally, this config folder contains an environment folder that allows you to change any of the config settings on a per environment basis. Alright, so that covers where you specify your routes and how to modify the default configuration for React Router. Let's head over to our components to show how to use React Router. Since React Router is already integrated into your project when it's first created, you can immediately dive into your components and start referencing React Router. The usage for React Router doesn't change, as Lore doesn't modify or obscure any of the libraries it's built over. So if you want to make a link clickable, you could just import the link component from React Router. Or if you needed to change the route programmatically, you could grab router from context and use that directly. To summarize how Lore helps with React Router. React Router is already integrated when your project is created, which means you can just create components and access the router as you need. The routes are clearly exposed at the project root in routes.js for simplicity and clarity. And settings can be configured from config/router.js as well as overridden on a per environment basis as desired. And putting all of that together, Lore basically allows you to ignore React Router until the needs of your application demand that you can't. Alright, so our last vacation destination is publishing. So the typical deployment process looks something like this. First, you decide where you want to deploy your project. Then you have to learn how to deploy your project to that platform. And then you actually deploy it. And that process typically looks something like this. If your project's already built, you delete the build directory. You then configure Webpack for production. You build your project. You push the build directory to the server or the platform that you are deploying to. And then optionally, you might delete your build directory once you're done. Now, outside of being a resource to compare and contrast different hosting providers for your application, Lore can't really do much to make the selection process easier. But once you do decide, it can help a bit from there. At the root of your project is a gulp file. And just like the Webpack config, this file is really just a wrapper over this directory. Inside this directory is a default gulp task, which you can totally ignore as it's just a placeholder. But that's not what we're here for. We're here to deploy to Surge. To do that, you're going to run a CLI command from the root of your project, lore generate surge. This CLI command will place a gulp file called surge into your tasks folder. Once this file exists, assuming you have a Surge account created already at this point, you can simply run gulp surge and give it the name of the domain you want to publish your code to. At that point, Webpack will execute and build your project, placing the result in a build directory that will get pushed up to Surge. And once that's done, you can visit your project on its new home. To summarize how Lore helps with publishing, it provides pre-built gulp tasks for publishing to popular platforms, which means when you're ready, you can pretty much just drop one in and push your code up. This also means that you can largely ignore publishing until the needs of your application demand that you can't. And with that, we reach the end of this video. To quickly recap what we covered, building a React application today is a bit like an uphill climb, as there are a lot of libraries that we need to learn in order to build a functioning application with a good client-side architecture. Lore takes a page from server-side frameworks and uses conventions and sensible defaults in order to turn the uphill climb into something closer to a resort island that you visit and play around in. Lore's goal is to provide an experience that allows you to focus solely on your React components until the specific needs of your application require you to dig in and learn more about one of the libraries that Lore uses as its foundation. This approach is designed to create an experience where you can learn about things when you need to, and they stay out of your way until that point. In a future video, we will build a real application with lore so that you can see it in action. Until then, take care, and thanks for watching.